Hello and welcome to my recycler robot video. Let's get started by getting right into the build. So they say the first step to engineering is to look at what someone else has done, and in this case that's exactly what I did. I just copied the exact tank track platform from a previous class, and that turned out to work really well. All it really consisted of is the 11 by 10 platform, I think it was, and then there's two on either side, two 90-degree brackets that hold the front two gears for the treads, and then in the back there's one 90-degree bracket, and that's just for a servo. And that exact same thing is mirrored onto the other side. So the next part of the build was going to be how am I going to actually lift the claw into the bins. And what I saw was when I looked at one of the tank treads in the parts bin, they actually had holes, and I figured, oh, I could probably attach something to there, and in this case the claw. So I figured I could basically have the claw go up and down, and then it would go up and over, and then release the can, and there would be some sort of sorting mechanism, which I later decided would just be a flap, and then that would direct the can into a left or right chute. So after I came up with the lifting mechanism, the next thing that I was going to have to design is the claw. And in this case, it was really important to keep things lightweight because of the way that it actually works being attached to the conveyor. So all it is a 90-degree bracket and then a flat piece attached to that. And then the claw is just a simple direct drive gear with two gears connected to it, and the servo connected to one of those gears. And the claw itself is kind of shaped like about 120 degrees, and then there's a rubber band run from the outside to the inside of the claw. That way there would be something soft that could squeeze down onto the can, because I did notice that a lot of the cans were kind of crunched up, and this way it could account for if it was crunched or not, so it could basically squeeze down onto anything and not damage the servos as well. And then the other thing was the line sensor is installed on there, and that is what actually determines the color of the can so that it can be sorted later. And then lastly, I had to figure out how I was actually going to do the sorting. So what I did was I just found the 84 tooth gear, and it had a lot of points for mounting, so I figured I could use that to attach my flap to it. And I designed the flap in SolidWorks by downloading the gear off of Vex so that I could get the exact measurements. And then I 3D printed it. The next thing that I got into was actually testing the mechanisms themselves. So I just made a simple servo tester program, and then I connected a potentiometer, and that potentiometer would be used so that I could drive the servos, and then also the PWM values of the servos would be displayed onto the LCD so that I could then use those values to determine what position the flap needed to be in, the claw, and then how fast the conveyor needed to travel in order to lift the can and claw up and down. And this was the part when I discovered that I did not have enough torque for the conveyor system. So what I ended up having to do was I relocated the DC motor so that it was at the top, and then I printed out a big 84 tooth gear, and I actually used the printer one back on my flapper mechanism. So I put that back over there, and then I used a nice nylon one on my new little gearbox here. So then I actually had to print a 12 tooth gear. And I decided to do that because I was working on this at home, and it was faster for me at this point to do that rather than wait to go to Open Lab or go to class to get the parts. And I had everything on hand, so I just went ahead and did that there. But that ended up solving my issue, and now the claw moved a lot slower and with more torque. So That way it would actually stop in any position and it wouldn't go too fast into the limit switches and break itself. And now here I am testing the actual line tracking and picking up of the cans. I found really the parameters that I had to tune around with was nothing with the line following, it was just with the ultrasonic sensor. And that had to be stopping it pretty much exactly at 10 centimeters because it needed to get close enough to where the line sensor was located on the claw. Now, if I were to go back and do this again, I would have actually relocated the line sensor onto the side of the claw, and that way where the ultrasonic sensor is detecting the can wouldn't have to be super precise because the line sensor would always be a fixed distance away from the can once the claw closes. So that was a little issue that I had to tune around with, and it had to be, the way it worked is it had to stop exactly at 10 centimeters so that the line sensor would be at the correct distance to correctly get the color of the can. So once I was happy with the claw, the conveyor, and the sorting mechanism all working, then I was ready to install the box on there so that it would actually contain the cans. And I did my tests, and I was pretty happy with how it all worked. So I was pretty happy. I ran it a few times at home. It was going on my line follower track on the smooth shop floor, and it was sorting cans and having no problem. And I made the mistake of thinking that that would also apply for the real course in the mat, with the mat, and it did not. Unfortunately, this didn't turn as well, and I showed up on the final day with 2 hours left, and during that time I couldn't actually figure out how to get my line follower to work. So what happened was I showed up, I put it down, and literally the very first run that I did was the one that worked the best. And it made it a little past halfway through the course, and once it got to the third can, it slightly overshot a little bit, and that was because I was so confident that I even turned the speed up. And when I turned the speed up, it of course caused it to overshoot the ultrasonic sensors 10 centimeters, and when it dropped the claw, it ended up dropping it on top of the can, and then that run failed. And once that happened, I kind of proceeded to panic a little bit, and I changed the code for my line follower, and I didn't actually get a line following run anything better than the first one. However, I did do an assisted run, and it did sort 4 cans and pick them up successfully. So overall, I was pretty happy with how the project went. I guess I just wasn't happy with my poor time management skills. And yeah, I thought I could just get away with only using class time and working at home, but yeah, I definitely needed to show up for the open lab to really do the mat. Now that I have a clear state of mind looking back, I think what I should have done was just not change my code at all. I should have made it go slower. Really, all I needed to do was adjust how it turns, because that was where the issues were coming up. The mat, I guess, causes the tank tracks to kind of get stuck a little bit, whereas my garage floor was smooth and that allowed it to slide. So really, I just needed to spend some more time messing around with the motor PWM values, and I also needed to change the threshold so that it was even lower. But yeah, what ended up happening was I switched to a simpler version of the line tracking code, and it was no longer as precise, so the claw wouldn't line up exactly with the can, and that's why I had to assist it a little bit. But overall, I'm pretty happy. I learned a whole lot, and I really enjoyed this. I'm traditionally more used to just doing mechanical stuff, so this class has really helped me a lot actually understand what's going under the hood with coding and logic design in general. But thanks for watching, and yeah, I had a fun time building this robot.